Hello, I'm Abhi. I'm a fifth-year PhD candidate at ESA, where I'm working on the operations of the cultural industries. First of all, I'd like to thank the Service Science section for selecting our paper as one of the finalists in the Student Paper Award competition. I'm really looking forward to getting to the conference and actually presenting this in person. In this particular project, we try to see how people make sequential choices whenever they are consuming experiences, and these choices are made available to them in a physical and a digital layout. Of course, we explore this particular question within the context of museums. And in the next 10 minutes, I'd like to give an idea about the overall question that we are trying to look at, the approach that we take in a very brief manner. But then, of course, more details about the paper are actually available in the paper. Having said that, so let's begin. Now, I mentioned layout, but what do I really mean by it? And for that, we need to go to what the basic function that every museum across the world faces. And the question that they have to really decide upon is essentially they have a network of locations, they have a bunch of items, and the decision that they face is essentially allocating a particular item to a particular location within the museum, so as to create a better experience for you as a visitor who goes to the museum, or to have a better engagement for the visitors, or to have a better resource utilization. So, for example, to reduce or minimize congestion within the museum. Now, before I go into talking about what we do within this paper, it's important to juxtapose against what would happen if these decisions are not made in an optimal manner. For this, I would like to show you a series of pictures that we took in Louvre in Paris, where right off the bat we see that within this particular room, where obviously Mona Lisa is housed, you have a very high congestion level within the within that particular room, where you have an extremely long and winding line that you have to get through to actually interact with the artwork. So that's problem number one. The problem number two shows that the kind of interaction, even when you get to the top of the line, isn't that quality. So, and not from that particular distance, not through the glass that is hanging over Mona Lisa. So clearly that's another problem. And then problem number three is something that always breaks my heart, which is essentially this particular room is called the treasure room because it houses some very influential artworks, but hardly anyone is giving any attention to these other artworks within the museum. So there's a clear shadowing effect. So the question becomes, can we make these decisions, layout-related decisions, in such a manner that these problems can at least be avoided? And if we can go a step further to have a better experience, can we have better experience for people who come to the museum? When you extrapolate this problem, it can also be thought about in the context of retail stores like IKEA, where you go in and you have an experience of shopping when you go to an IKEA, or you have an experience on a particular website. So how can you design a website for a better transition of the art of the people within who are using your website? Which brings me to the central question and the contributions that we are making within this paper, where we try to see how to model the sequential choices that people make as a function of the digital and the physical layouts, for which we build a model which is of the multinomial logistic structure. By collaborating with a museum, we get a very granular level data about how people move within the museum, and we empirically and economically measure what is the effect size of each of these different factors that we have in our model. A few out of sample validation tests and numerical experiments provide further validation to our methodology. And then we try to see, after learning all these things, we try to see if we can actually develop better layouts for the museum so as to maximize the engagement of the people who come to the museum. Having said that, let's get to first talking about the collaboration, the very exciting collaboration that we have within this project, where we get the chance to work with the Van Gogh Museum, which is one of the most influential museums in the world, houses the largest collection made by Van Gogh himself, gets about 3 million visits every year, even though it's quite small in size. Infrastructurally, the museum is divided into 4 floors, including the ground floor. It's also important to know that every floor is divided into multiple rooms, where each room has a particular theme associated with it based on the artworks that are housed in that particular in that particular room. But then the question becomes, how do we actually get to track the way people move within the museum? And that essentially is done by looking at the data that we gather through the audio guides. So audio guides are pretty standard offering across museums across the world, where you have audio clips related to an artwork. You go to an artwork, you press the number associated with it, you listen to that audio clip, and you connect with that artwork in a better manner. This particular data allows us to track people's movement within the museum in the following manner. So the graph here shows these nodes, which are artworks, and the arrows show the number of transitions between these artworks. This data is available from 2019 to 2021. We stick to the pre-COVID era. We get about 33% visits of the total visits that come within the museum. Visitors that come within the museum. It's also important to note that the surveys carried out by the museum show that there's not much difference between the groups who actually decide to buy the audio guide and who do not buy the audio guide. This data is available for 28 artworks and is available, and the audio guide itself is available in 11 languages. Now, this becomes on the side of the layout, but what about the artistic element that is depicted in the artworks that we are trying to model over here? For this, we make use of the public datasets like WikiArt, which is a sister website to Wikipedia, very detailed insights into what is depicted in an artwork. And to support this, we also make use of deep learning techniques. So we use convolutional neural networks that bring down the dimensionality of what is represented in an artwork to a lower level vector, a much manageable vector that is then used in our empirical analysis. This brings me to the model, where now we have all the elements essential for building our model, where we're trying to track the way people move within the museum. So what is exactly going on here is essentially you have an allocation system where an artwork is allocated to a particular position with assignment I. A visitor comes in the museum and takes a path sigma. Suppose at each step, a particular visitor is at sunflowers. At this particular point in time, they can go to any of these artworks, or they can also leave the museum, which is again normalized to 0. And this is essentially the step that we are trying to model in our modeling framework, for which we develop a conditional logic form where the visitor makes the choice of selecting one particular item out of the assortment of options that is available to them. So for a visitor V at position K, who has a particular choice set, the likelihood of a person to choose artwork I depends on the utility structure as given in this particular form, where the first form of this utility depends on the physical and the digital layout. So it depends on the distance in terms of your physical distance with the potential option that you may go to, or the digital distance, so on the audio guide itself. The artistic factor, so the kind of transition you would want to make, where you are in terms of artistic themes portrayed in the artwork, and the potential option that you may go to. And then the contextual factors, which are related to the time that you've spent within the museum already, or the congestion within the museum. Now, we use this model to build an empirical specification, which is then fit to the data that we have available. I'm not going to go into the details about it, nor am I going to talk about the results, which are, again, available in the data. I would like to go to the optimization framework, but before that, I would like to also highlight the validation tests that we did. So out of sample prediction, a test actually shows us that our model is 64% times 64% accurate. Also, the natural experiments that happen within the museum, where a few layout-related changes happen, which were related to construction-related changes that happen within the museum, which were exogenous to any kind of museum, the visitor movement. We try to see whether our model is able to predict these changes in terms of the way people move in the transition probabilities. So, for example, Yellow House was moved in this particular week in November from floor number 2 to ground floor. Sunflowers was moved in the following week from the floor number 1 to ground floor, and so on. And in the paper, we show how these changes are actually reflected in the way people move within the museum, so in their transition probabilities based on our model. Now that we learn all of this, can we help the museum to build a better layout, which is essentially the end goal of this project? We hence we formulate the layout optimization problem, where we are trying to maximize the total number of artworks that people see within the museum. Hence, we're trying to maximize the length of the overall visit within the museum. We show that this problem, even in its linear form, is NP hard. In its interactive form, it's NP hard to approximate. Then we build simple heuristics, which are based, which try to leverage the attractiveness, the retention factor of the artworks, which we find from our empirical specification. And then we also carry out these simple greedy swaps. Overall, to summarize these results, we show that based on these enhanced layouts, the museum can actually increase the engagement from about 0.56 to 7.47 based on different policies that they can implement that we suggest in this particular paper. One particular example that I would like to highlight over here is a greedy swap that we carried out, where this is flow number 1, where you have a few artworks on there. Here we make a transition, or we swap the position of potato eaters and Zouave, which is all the way into the end of the room, and we try to see what would happen on the engagement levels that are observed. Here we see that whenever potato eaters is swapped with Zouave, potato eaters itself has a positive impact, which is again a very popular artwork by Van Gogh. But Zouave, because it went to a very prime location, also had a very high impact on the engagement levels. And also, these effects are not limited to the artworks that are only the ones that are swapped. You see a positive spillover on most of the artworks that are around potato eaters' new position. So overall improvement happens about 0.7%, but then spillovers are observed, and essentially this particular mechanism also works into the layout related heuristics that we propose. Overall, in conclusion, I would like to say that in this particular project, we try to model the way people move within the museum, which can again be extrapolated to other contexts. The model that we develop is general enough. Again, by using and collaborating with the museum, by using real-world data, we empirically measure what factors and what effect they would have on the way people make these decisions. And then we also try to build an optimization framework, which is targeted at maximizing the user engagement. Finally, this particular project has led us to a couple of other projects where we are trying to actually carry out experiments based on the results and the findings in this particular project, where the museum is curious about how our recommendations would work out within the museum. And hence we are actually right now working on 2 different field experiments within the museum, where we are making changes in the digital layout of the artwork, and we are trying to measure, and then we are seeing how that affects the way people move within the museum. Having said that, I would end my presentation over here. And again, I'm looking forward to coming to the conference and actually presenting this in person. Thank you very much for this opportunity.